Hello and welcome back to the show. My name's Irrelevant. This is Do All the Things. We continue once again on the Soldano clone build project. And on today's episode, we start wiring up the chassis. Ho. Partially fun. Not as fun as doing the boards, but hey, still fun nonetheless. Let's get into it. Alright, so one of the first problems we run into here, because I am repurposing a transformer, is none of these wires are going to reach anywhere near where I need them to go. Now, I salvaged this nice piece of brown wire out of a computer power supply to connect to this IEC, and as you can see, I have the ground done properly, not to the star ground. Chassis ground goes to the chassis. You're going to notice on these IECs, they're mounted line and neutral. Line is going to the fuse. We need to get this fuse to the switch, and then we need to get these mains hooked up, and to do that we need some wire. Now the only 18 gauge wire I have in stock is green. I'm deciding that I'm going to salvage wire off this blown transformer. It's got some nice pieces of wire on it that should be long enough. This is actually came out of the Jet City amp. As mentioned, it came with a blown power transformer, so this thing's of no use to anyone anymore. The wire on it's only 20 gauge. I'd like to use at least 18 for the mains, but well, we're going to the fuse. The wire going to the fuse is 18 gauge, so anything smaller than that's fair game as long as it's within the rating of the fuse. And indeed, this amp's rated for a 3 amp fuse. That's on 100 watts. This is actually a 50 watt build, so it's not even going to come close to exceeding what a 20 gauge can do, even on the mains. But we have 600 volt, 105 C rated insulation on this transformer, so that is quality add. Now, one common color code we might see on a neutral wire in some countries is blue. It's white over here. Should I use white or should I use blue? You know what? I'll use white. We are domestic. Well, we gotta give her a little snip, right? A little bit of snip, just to get those wires fresh for the twisting. Yeah, I think this is probably 20 gauge too, actually, right here. This is some nice looking wire they have in this transformer. Where are the mains wires? These are the mains wires even. Little bit of twist, and tack it up. All right, that looks good. Now I just need to size this piece of wire. I want it to come and sit flat as possible and come down and up right about here. I feel sorry for this transformer, but hey. Now, one thing that didn't come with the kit that you're probably gonna need, especially if you have to extend leads like this, is the good old heat shrink. And I don't have a fancy heat gun, but got a torch. Works for me. I need to train that wire. Now this is in a precarious spot over here in this corner, but we got it on there, and now she's nicely soldered into place. We have neutral. We're gonna need most of this wire to do it the way I like to do it. Oh yeah, no more mains wire for this transformer. There we go, committed. Never use that transformer again for anything. Now, I don't know if there's a rule on how you should approach wiring up a fuse holder. I like to put the one on the end to be the hot side, and then the one on the inside to be the contact side, or the pass-through. The idea being that whatever has the mains applied to, it's further down in there. And of course, because of the way I positioned these, it's hard to get at that lug. But I did that so that on the chassis itself, you know, the fuse holder smiles are sitting nice. You tighten them up, they're gonna stop, bam. That should be good like that. Now we just wanna train our wire. I want it to follow roughly the same path here. And on switches, hot, I'll put it on the center lug. And unfortunately, that's easy to get at. Sometimes if we strategically heat up wire, we can have it hold its form. There we go. Main switch connected. Now we just have to get the other lead on the transformer on there. Maybe we'll use a piece of red wire this time, or no, brown wire. I may start implementing the use of zap straps in here actually, and wire holders. Yeah, I want this to run kind of like that. Down, round, up, something like that. Okay, it's happening. Thomas and Betts, UL listed. There it is. Our transformer now has mains power. And this, I managed to lay it out so it's low profile. It shouldn't interfere or touch the power supply board. Now, the heater wires here, I'm gonna go ahead and tack them down now because they're not going to move from that position. Yeah, I didn't have a single triple terminal strip that was big enough for all the wires. I have some, but they're smaller. I would have had, they didn't have a base hole big enough, and with how much stuff I have to hook up to here, this is better. So I used 2 singles, and that's fine. I'm gonna solder the wires down in the terminal strip's hole there, and then everything else that I need is gonna hook onto the actual terminal strip. Because this wire is not moving from here. So that's our AC heaters. While we're on the topic of AC heaters, let's get that pilot light ready to go. While we're on the topic of AC heaters, we're gonna need a drill. You gotta get the wires into pincers like that, and nice! Except it kind of goes after. Might be a little bit of trick to training it. I was actually just a touch too early to strap these down, so we might end up wasting a few of these zap straps as we go along, because I'm probably gonna run the standby run along there too. Come on, bud. So I'm gonna get these wires ready on the terminal strip, but I'm not gonna solder them down because there's other stuff that needs to get soldered down onto here. Oh wow, this is way more wire than I need. Now we have the pilot light hooked up. You can barely see the wire, it's a bit hidden. Just to satisfy my own curiosities, I kinda wanna give power to this now. I'm gonna put some covers on these hot wires to safely cap them off. These very hot wires, sir. Really? 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 That should be safe to fire up now. Gotta put a fuse in there first. So yeah, if I plug power in and it's purple. Yay! Progress. So one of the next things I'm gonna do on the layout, it shows pretty much a wire going from the HT fuse to the standby switch. I'm not gonna use salvaged wire for that. I actually purpose bought wire to do the high voltage. 20 gauge 105C, 600 volt insulation. That's what you want for this application. And it's purple. Purple. So from the power supply board, it goes to the standby switch, then the standby switch to the fuse. There's a lot of stuff that needs to hook onto that fuse. Namely the choke, which is right here. Yeah, I need to go out and get those wire. Oh, this thing does not like stripping this wire. I'm gonna want that to come around the back of that black wire, then through, along, around, and then up to the center lug. Yeah, it's time to get more zap straps. Wasted. This wire's got a mind of its own. I don't want it to contact that ground lug. We need to rotate that hard point. Okay, just this one last connection to go. Woof. This is good, tough insulation, eh? All right. I do believe that particular section is done. Now, you're gonna waste a few zap straps as you find better ways to do things. But here we have, yeah. Now, part of the philosophy of doing something like this is you end up with something forming a self-supporting trunk. So this zap strap here is making contact with the chassis, but the rest of these are pretty much hovering. I could put another zap strap here. That would be a good idea. Yes, and now this wire is no longer making contact with the chassis. The only hard point we have is against this standoff here, which I've put a couple layers of heat shrink tubing on there, and then nothing's touching the ground wires. All these wires are floating nicely. On the switch end of things, all these wires are floating nicely, and you can see the 2 mains wires are not touching, and because they're held into place, they never will. Now, one of the philosophies behind this method of cable management is to avoid vibrational erosion. The idea that this amp running, sitting on top of a cabinet, inducing vibrations, these wires are going to subtly vibrate. And if you have them making contact with something like against the chassis, against that standoff lug, you can have it slowly erode away at the insulation and eventually have a short circuit in a long period of time. You do this, well, all these wires are secure. We're never going to have any problems with this mains connection. Now here I'm extending the wires off the 5 volt to run the switching circuit, and sometimes if your solder joint has some sharp on it, you might want to give it a bit of a filing to smooth it down, or else that sharp will just, cut its way through the heat shrink tubing. Actually doubling up the heat shrink on this to keep it nice and together. Togetherness. Yeah. Yeah, right up to the switching circuit, no problem. I had to loosen up the pilot light because it's damn near impossible to get the board in place unless I do. It sticks out too far. Because I got to start sizing up where these wires are going to go. Unfortunately, none of these wires are going to reach. Now right here, we have the center tap for the 6-volt heaters and the center tap for the B+ main supply. And we're getting a little bit creative here because these both get grounded out. So I'm essentially combining them onto the same wire because they're both going to get grounded out to the star ground. With some fresh 18 gauge green wire, I'm going to make it all one nice piece. I'll heat shrink this later once I've cut the green wire to length. Until I need more green wire, I just leave it connected to the spool like so. I want to kind of train these to sit flat down here like this. And finally, I need to extend these guys. These guys are also going to get fresh purple wire, or maybe I'll give them red wire. How far extended do they have to get though? I want these all to sit as flat as possible. Origami of wires. Origami wires. How are they going to sit underneath this board now? Yeah, I'm not feeling resistance under the board anymore. That's good, that's good. This guy has to come up around. It's going to connect to a star ground right here. These guys, literally, they just need a couple inches over to here. No, over to here even. So maybe I actually want them to go this way. Wires to go this way. Have these guys come out this side here. Because they're going to go right here. And possibly upwards. Yeah, these guys are getting fresh. Fresh, that's what I bought it for. Okay. All right, I think we're mostly done in this area. We have our leads extended. There's our ground. There's going to be our AC high voltage. Probably going to, once I figure out exactly how I'm soldering these into place, might add another zap in around this area here. I don't want that to rub against that, but I'm thinking that once I install these, they're going to clear. Maybe I could have them come around here. I think it's going to hold it away from that. I put 2 straps on this line here to stop that from rubbing up against there. And oh, it looks nice. So now this is all relatively flat and trained in such a way that if I drop this guy into place, yeah, it just sits nice and flat. I don't feel wires pushing up on it. I am taking this to the next level though. In old computer power supplies, they have these isolation sheets. And this is making it into here. Because in the event that a wire does vibrate, I don't want it grinding up against the solder joint. Some of these are pointy. And this is, you know, just about the right size. It's perfect. A little bit of flippity floppity here. It has an index hole even right there. So we go based on that hole there. It's amazing how much the right size it is. Almost, eh? Almost perfect. Just have to trim on it a bit. And yeah, now it's going to act as isolation, preventing those wires from being able to grind against the solder joints. These wires will come up against here. I almost want to see if I can get them to come in from the bottom, but nah, we'll keep it simple, just like that. And then this is going to go to the star ground. It's a little long. Yeah, I feel like these are going to touch something. At what point am I ready to officiate this? I think I'm going to put more straps to train this lead line. Oh, that's going to make it damn near impossible to touch that. Choke's all the way over there. I'm gonna have that come around this way. More straps. We tell those wires where we want them to go. Till they leave the underneath of that PCB, they'll be very strategically placed. Now mind you, I might have heater routes going this way, going to that first tube and going to the DC board. So we'll leave this loose for now. I think it's time to make up some heater wire. Yeah. Hold on, I might want more than this. Seen here, one last hurrah, ready to supply the DC heater board. I keep trying to think, oh, is this the last I need to be under this board? Does the board still sit nice? It's starting to push down, but there's no tension. Yeah, okay, I'll keep that like that. Little nubbins. So bias in is subject to controversy. Because bias in, we don't have a bias supply in this transformer. We have to tap it off the AC. And it says right in the instruction, if taking from the HV tap, make R76 220K 1 watt. That guy right there. And I knew that. So we have to fit a 220K 1 watt in there, shared with this guy. Let's solder that pupper in there and hope it's the right amount. It should be, because the output of this transformer is close enough to spec. If it's not, I'm gonna have to open her back up again. And we are committing now. I'm gonna start soldering some of these wires into place. AC is going in that shared hole. I have to start getting a ground bus ready. I have a black 20 gauge 600 volt 105C rated, and I'm hoping to use some trickery with this. I'm doing a mid strip trick. I'm hoping if we fold that in half and give it a nice twist, well, it's one single piece of wire. That goes into this ground hole, even though that's gonna have to get trimmed. I'm using a scrap piece of blue wire off the transformer for the bias color code. Bias out, right there. Finally, I'm gonna put white from the choke onto here. But then the choke, well, that's not the only wire going in the choke hole. It has to return back out to feed the screen grids. And we're gonna use a brown wire off of the scrap transformer just to get some color codes. Finally, keeping with my purple color code, our B+ output. Oh, now we trimmed these guys down. Actually, no, we got one more going to the standby. Almost forgot about that guy. Yeah, we'll use a piece of red. Now, all these connections made, and some of them getting in the way. Get these spools over on this side. These will sort out easier after. Might have to start cleaning up in here. And if I fold this over, plopper it to place, our power supply is complete. Just gonna inspect for clearance. Yeah, that looks good. This ground wire will go over to the star ground, and then, yeah, well, these connect to this board over here, which we're not ready to do yet. Just kind of going with the flow. Seeing here, I'm just finishing up the accent lighting, some LEDs going across the back of the chassis. I skinned off a bit of insulation, then stabbed a pin through to get underneath the wire. That way I kind of made a pinhole to stick the LED through. Now we just tack a little bit of solder on there and boom, we have our light. There's a certain amount of touch to this because you can easily burn away the insulation. But if you do it right, it's gonna be spaced out in such a way, you're not gonna have to really worry about heat shrink or anything. They're never gonna touch each other. And it just kind of runs along the back of the chassis. There's these little holes that we've drilled and put the little LED holders. Just these little plastic things you can get that LEDs snap right into. Snapping them in can be tricky. They kind of want to push out. Got to get like a little screwdriver that wedges in between. There. They're blue LEDs. Blue's his favorite color, which is great because now I have a purpose for all those obnoxious blue LEDs that I pulled out of electronics and replaced with red ones. And, these wires are just gonna run up to the DC board right about over here. So now at this juncture, my interest is hooking up the output transformer. So this red wire, one of the more important ones, that feeds B+ to the output transformer. As you can see, it's probably not long enough to reach the fuse holder, which is out of frame right now. So I have to extend it. Oh, this wire will tuck behind the LED holders, will it? Quite nicely. Again, scrapping wire off the old power transformer. Whoa, never had that happen before. A bubble in my heat shrink. We need to get these speaker jacks out of the way. They're going to need some adjustments anyway. First, before I lay that out, I'm gonna get these wires connected or extended. We need to lengthen this black wire that is the ground or the negative coming off the speaker side. So at some point, the speakers ground to the chassis, or they ground to the ground bus. The negative of the speaker gets grounded out. And in the Jet City, they do it right on the chassis, so that's kind of what I'm gonna do here too. That means I have to polish away this material to get a nice spot in which to do it. I'm gonna attempt to use a conventional wire brush because the friggin' Dremel was so annoying. Okay, looks like the Dremel's better at this. There's gotta be a better way, man. Like a sanding disc. That should do it. I'm gonna use a jack with one of these aggressive claw-like washers. We're gonna put it on loose for now though. Or wait, that's the wrong jack. Why does this one not have a... Buddy just used whatever jacks, eh? Man, these are dinky jacks. I don't much care for them, sir. I don't much care for them. Oh, cutting it close. Now the speaker wires in particular are 18 gauge. Unfortunately, the only 18 gauge I have is green, so we're gonna start having our color codes go wonky on us. It's gonna be fun to get all this wire into that little hole. We should get the other piece ready to go. Let's remove this thing. I feel like I can secure these down now. I gotta get all the output wires connected to this here multi-switch. 16 being this position. And 16, according to my write down, is the purple wire. Now I gotta plan ahead. Yellow is 8. That'll be the next one down here. And the orange, yeah, okay. We'll start down here. Orange is 4, correct? Orange is 4. And orange being 4 is tricky because it's also the feedback tap. We better grab a wire for the feedback signal. Tack it down. Let's move to yellow. And finally the purple wire. Aha! The speakers are all hooked up now. Yeah! I just have to estimate the positioning of this feedback wire, which is gonna feed under here. So, this guy, the big B+, that has to go and attach to Mr. Fuse Holder over here. These wires shall get bundled up. This tucks nicely behind there. And that is gonna come around like that. And also, the black of the choke is gonna go on there. First, I need to space this choke wire nicely, which requires me adding a wire hanger in a spot you can't see. Come on, give me just enough width to do that. Ah, you're just too small for that one, eh? I just need to snug that one last nut up. That B+ wire goes over this choke wire. Ugh. That took a while to set that up. Why is the solder not flowing onto that contact? Yes, now let's get it up here. Come on now. There. Oh, that's the main B+. Yo. Now I have to do these tube lines. And for this, you have to pay attention to the board. The board orients this way. Now you see here, I have a mark. That mark is for the blue one. The blue one on this transformer connects to the half of the circuit that has the 82K. So you gotta go looking for it in there. That's not the same for all, but for this one, that's the case. So that means I'm gonna do blue on this guy. Pin 3 right here. They don't explain in the instructions how to phase up your transformer. Now, it doesn't matter until you add a feedback circuit, and then that feedback circuit has to be in the proper phase. And the feedback circuit's proportionally gonna come from the 82K side of the phase inverter. You find out pretty quick if you phased up your transformer wrong because your amp's gonna howl and squeal when you turn it on. As that goes out to pin 3 circuit. Ah, we have our first tube socket connection. Now I have a bit of scrap brown wire. I'm not sure if it's gonna be long enough. It might. Oh, just bud. Oh boy, there we have it. The speakers and the output transformer is all completely hooked up. And I do believe this is the last wire I'm gonna run down this particular trunk here. So I'm gonna start strapping it down. Feedback's hiding where? Oh, I'm following the schematic too intensely. The feedback wire goes to here, but no, this is a friggin' layout for the Mark 1. The Mark 2, the feedback wire has to go to the depth knob, which isn't even on here. And then it goes to here on the chassis, you can't see it. So this feedback wire is too short. I need to pull it all back out and cut another one. Fortunately, I think I'll be able to fish it through some of these zap straps. Unless I cheat somehow and extend this wire. I think I'm gonna do that actually. It's not really gonna be a big deal. I don't know, I'll think about it, but either way, it is late. I think I am done for today. We've got the power supply board done, wired up, the power transformer wired up, the output transformer wired up. I just have to fix that feedback wire. I'll do that on my own time. And then you're gonna join me for the next part, where we're probably gonna start up front here with the potentiometers and the switching wiring, and stuff's gonna get even trickier because we were dealing with big wires today. Now we have to start doing small wires. Oh boy. But then there's other things to do onto the tube sockets here too. So that's probably gonna get spliced into the next video also. So stay tuned and come back for more SLO domination. Never blindly follow the schematic. Oh well.